This is your second reading or notes activity for the Earthquakes and Mountain Building module. Seismic waves and Earth's interior. Here we have our diagram of the Earth labeled with our 4 sections. So we have the inner core, then the outer core, then the mantle, and finally the crust. Notice the crust is the thinnest part. With that, you can go ahead and answer question number 7 in your science notebook. Clues to Earth's interior. The seismic waves that shake the ground during an earthquake also travel through Earth's interior. This provides information that has enabled scientists to construct models of Earth's internal structure. Therefore, even though seismic waves can wreak havoc on the surface, they are invaluable for their contribution to scientific understanding of Earth's interior. Seismic waves change speed and direction at the boundaries between different materials. Note that as P waves and S waves initially travel through the mantle, they follow fairly direct paths. When P waves hit the core, they bend and their direction changes. Seismic waves also reflect off major boundaries inside Earth. By recording the travel time and path of each wave, seismologists learn about differences in density and materials inside Earth. What happens to S waves generated by an earthquake? To answer this question, seismologists first determined that the right angle motion of S waves will not travel through a liquid. Then, seismologists noticed that S waves do not travel through Earth's center. This observation led to the discovery that Earth's core must be at least partially liquid. The data collected for the paths and travel times of the waves inside Earth led to the current understanding that Earth's core has an outer region that is liquid and an inner region that is solid. You can see in this here, we have the density is displayed here. As we get further and further inside the Earth or towards the core, the density increases. And then we also have the depth. So we're seeing how far in towards the center of the Earth. On the bottom, we see the velocity, kind of relatively how fast these waves are traveling. So we see that P waves are always faster than the S waves. And in the crust and then the mantle, we both see both the S waves and the P waves, and they're both going fairly straight. And then at the edge of the outer core, the P wave bends and continues through that outer core, but there's no S waves in the outer core. That's how we determined it was a liquid. Then we get to that inner core. We do again see S waves. And again, the P wave gets bent a little bit because it is a different material. Pause and go answer question number 8 in your science notebook. Earth's composition. The 2 cross sections of Earth show that seismic waves change their paths as they encounter boundaries between zones of different materials. They also change speed. By comparing the speed of seismic waves with measurements made on different rock types, scientists have determined the thickness and composition, or what stuff it's made of Earth's different regions. As a result, scientists have determined that the upper mantle is peridotite, which is made mostly of the mineral olivine. The outer core is mostly liquid iron and nickel. The inner core is mostly solid iron and nickel. P waves in the outer core are bent. This creates a P wave shadow zone on Earth's surface. There are no direct P waves appearing on seismograms. Other P waves are reflected and bent by the inner core. These can be detected by seismometers on the other side of the shadow zone. S waves cannot travel through the liquid outer core and thus do not reappear beyond the S wave shadow zone. Pause and go answer question number 9 in your science notebook. Earthquake intensity. The intensity of an earthquake depends mostly on the size of the surface waves generated. Surface waves gradually decrease in size as they get farther from the focus of the earthquake. Because of this, the intensity also decreases as the distance from an earthquake's epicenter increases. Maximum intensity values are observed in the region near the epicenter. Depth of focus. As you learned earlier in this section, earthquake intensity and magnitude reflect the size of the seismic waves made by the earthquake. Another factor that decides the intensity of an earthquake is the depth of its focus. Recall that an earthquake can be classified as a shallow focus, mid focus, or deep focus earthquake, as shown in the diagram. Catastrophic earthquakes with high intensity values are almost always shallow focus events. This means the more damaging earthquakes start closer to the surface. Pause and go answer question number 10 in your science notebook. Comparing P and S waves. P waves and S waves travel at different speeds through the Earth. P waves are faster than S waves. The farther from the epicenter a seismograph station is, the bigger the gap is between the arrival time for P and S waves. Pause and go answer question number 11 in your science notebook. That is it for your second reading notes assignment for the Earthquakes and Mountains module.